Hi students, in this video I am going to explain reaction intermediates. In previous video I had explained bond cleavage, that is bond fission, and types of reagents. In bond fission time we have observed reaction intermediate formation. Only formation I have discussed. But in this video, it's a stability order and remaining important points I am going to explain. And previous video I have said one point to you. It plays very important role in organic chemistry, the topic. The same like that here also I am telling this topic also, reaction intermediates also plays vital role in organic chemistry. First year as well as second year. Many times we are using these terms in second year reaction mechanism time. Carbocation intermediate, stability order, triphenyl and diphenyl, phenyl, like this vinyl, allyl, different species we are talking. But if you don't know this type, definitely it is very difficult organic chemistry. So please concentrate more along with me. You listen and make a notes. Okay. Reaction intermediates. Let's begin with first reaction intermediate, free radicals. In the previous, hope everybody have seen the previous video. In previous video I had explained how free radicals generated. If you are not seen, please go through that topic and come back here. Free radicals. First one, what is this? Electrically neutral odd electron containing species obtained due to homolytic fission. How it is obtained, everything I had explained that video. Please go through that. And free radicals is highly reactive species. Reaction intermediates, so if you are using if reaction intermediates more there in vessel, then reaction complete soon. Why? Because they are highly reactive. Highly reactive means fast it is attacking another species, other like that. Finally it brings the stable products. Okay, so next, third one, obtained in vapor phase in the presence of help. What is the point I have discussed in the previous video? Help, H, heat, energy, light, peroxide, and R is nothing but radical. Help presence we have observed in vapor phase. Okay. See, to understand more better, I had given example. This is methane molecule. In methane molecule, I am using sunlight. Sunlight, light means it is definitely homolysis. Definitely homolysis. Homolysis means what is the result here? Free radicals, odd electron, free radicals, right? So that's it. Now here, this bond, any bond you can cleavage, any bond. I am taking here this between carbon and hydrogen. I am cleavage. I am going to cleave. After cleavage, what happened? Equal distribution of electrons. This bond belongs to 2 electrons, right? Carbon is taking 1 electron, hydrogen is taking 1 electron. Finally, the carbon we are talking now. This is what we call it as methyl free radical. What is that? Methyl free radical. Methyl free radical, what is the story next? It has 3 bond pairs and 1 odd electron. 3 bond pairs and 1 odd electron in valency shell. So now I am showing point, students. Please look into this. Yes, afterwards we are going to discuss types also, stability order also. Yes. See, after cleavage we have got free radical. So it contains 7 electrons. Why it is 7 electrons, students? See, how many bonds here? 3 bonds. 3 bonds means how many electrons? 3 bonds means how many electrons? It is 6 electrons, right? 6 electrons. Because of this 3 bond 6 electrons, this is 1 odd electron, totally 7 electrons. I have written here 7 electrons is nothing but because of 3 hydrogens and 1 odd electron, or else you can write 3 bond pairs, 1 odd electron. So with this sp2 hybridization, how to calculate half into V plus M minus C plus A formula also you can use it. I had explained already this topic in chemical bonding. So 3 bonds, right? So 3 bonds. What is the valence electron? What is the number of valence electrons? How many carbon? 4. 4 plus 3, 7 plus this 1 electron, totally 8. 8 by 2, 4. 4 means sp3 we are getting. But see, one more point what I am telling, half into v plus m minus c plus a formula, right? Here, what is the carbon? Carbon, how many valence electrons, students? 4 valence electrons. 4, and the next one 4, and the number of monovalent atoms is 3. 4 plus 3, and this is minus 1. Minus 1, 6 by 2, 6 by 2, 3. You can go like that also, or else directly you can take it is sp2 hybridization. sp2 hybridization with planar triangular geometry. Which is sp2 hybridization? Definitely it can show planar triangular, not planar, not square planar. It is triangular geometry. Okay, now this is the geometry I have written here. These are hydrogens. If you want, you can write hydrogens, anything. In this particular case, it is hydrogen. Sometimes CH3 group, sometimes other groups also. So this is finally paramagnetic behavior. Why it is paramagnetic behavior? This point also we have discussed many times, which is having odd electron. Odd electron is nothing but single electron. Single electron is nothing but odd electron. That odd electron is there, definitely it can show paramagnetic in nature. And next exception case also there. We have exception case Cr3. Here 3 alkyl groups. Cr3 free radical, it is not sp2, it is sp3 hybridization, pyramidal geometry. Only one exceptional case we have, CX3Cr3. Next, types of free radicals. This is 3 degree. Types of carbon atoms, already in introduction part I had explained. This is 3 degree. How can you say this carbon is 3 degree carbon? Why? Because this carbon attached to 3 carbons. If you have any queries and doubts, please go through the introduction part. Part 1, Part 2, organic chemistry, then come back here, types. This is 3 degree. So because this carbon is 3 tertiary carbon. Why? Because it attached to 3 carbons. 3 degree, this is 2 degree, this is 1 degree, this is methyl free radical, and the next one, this is benzene ring CH2. Benzene ring CH2, then only we call it as benzyl. Okay, next this is allyl free radical. This is allyl, students. See, this is allyl, CH2 double bond CH2. Here propene, you know propene, no? CH3CH double bond CH2. Instead of one hydrogen, here I am writing radical, that is we call it as allyl free radical. Now stability order plays very important role, students. I am writing here stability order. See, I am showing this one. In previous session, I had explained one point to you. What is this? Carbon neutral condition only stable. Suppose carbon having like neutral, it is stable. It having, suppose it is having odd electron, it is unstable. Unstable condition, much time it can't bear, so much time it can't bear. Definitely try to go to the neutral condition, stable condition. How it will go? He has less electrons. He has less electron, 1 electron less is there. 1 electron. What is octet means? Octet means 8 electrons, right? But I had given here 7 electrons only. 7 electrons is unstable. It takes 1 electron get stabilized, go to the neutral condition, right? And the two octet rules we know, no? Next here, this carbon has been 1 odd electron. 1 odd electron is nothing but unstable only. Then he will take electrons from benzene ring. Benzene ring acts as both. It will give electron, it will take electrons. It will give electrons, it will take electrons. So it is giving electron. This benzene ring is giving, this benzene ring is giving, this benzene ring also giving. So all three ready to give. So one poor guy is there, 3 rich families are there, Ambani is something. So 3 rich families are there, definitely stable, right or not? Here also, here two richest guys are there, 1 poor guy is there, stabilize. He is giving electrons and he is also giving electrons. This is, we call it as conjugation. What is this topic? We call it as conjugation, or else resonance. We call it as resonance, conjugation or resonance. Now here odd electron, again unstable. Who is giving? Benzene ring is giving. Then such a way he is getting stability, stable. Now here see, he is odd electron, he is unstable. But pi bond is weak bond, no? Out of 2 bonds, one is pi bond. Pi bond is now giving electron. This one what we call it as conjugation. Conjugation. Due to conjugation it is more stable. Due to conjugation it is more stable. So this point many times we are using, students, please focus more. And next one, this one. Even free radical here. What is the free radical name? 3 degree, right? This 3 degree, actually you see, look into this carbon, he is unstable. He is unstable. But he is stabilizing by 3 rich families. 3 rich families. CH3 groups are electron releasing groups. They are ready to give electrons. Ready to give electrons. Giving electrons. Giving electrons. So I said just now, one poor guy is there. 3 rich families are there. Richest family, he is richest, he is rich family. So rich family is there, definitely he will give electrons. He is giving electrons like this, giving electrons like this, and giving electrons like this. Finally he will get stabilized. Okay, this topic you can understand more and more better after listening electronic effects, that is inductive effect. Okay, but here you listen, keep it in mind all the points, and upcoming videos I am going to do electronic effects, that is also plays very important role in organic chemistry, no doubt, due to hyperconjugation, due to inductive effect. Even this topic also, tertiary free radical is more stable than secondary. What is the reason? Due to inductive effect they were telling. What is inductive effect? How can you say? So a detailed explanation I am going to give in electronic effects. But here you can simply, you can remember, he is a poor guy. So okay, he is not having sufficient electrons. Then somebody is giving. Somebody is giving means happily can stabilize and stay. Okay. In the vessel, always it search stable condition. Stable condition is not there, he will search to the, he will search stable condition, it will go to the stable condition. Suppose methyl is there, methyl is unstable, it will go to the primary case. Primary possibility is there, it will go to the primary unstable. If it is primary unstable, it will go to the secondary, chances are there. Secondary also sometimes unstable, then most stable tertiary it will go. So after always it is rearranging to more stable form. Finally the highest stable form, that is products, he will bring. Because of reaction intermediates only, reaction will move faster. Okay, now this is 3 degree. This is what, students? 2 degree. This is 1 degree. Here also one poor family is there, poor guy is there. Two electron rich fellows are there, is giving electrons. Here poor fellow is giving electrons. Is here methyl, no one is giving, so that's why least stable. This is what vinyl. Vinyl is highly unstable. Suppose he giving electrons, after giving he is getting the same condition, no? That's why he is not giving. So that's the reason. See, after giving, what happened here? Condition CH2. Suppose he has given, then what happened? He will get like this. These two are, see, before here CH2, now here CH2, finally both are same. Finally both are same. Vinyl is highly unstable free radical. Finally, which is more stable? Triphenyl. Why? Because richest guys, they are ready to give electron. Keep it in mind, benzene ring ready to give electrons, ready to take electrons, depends on the partner, its action. Depends on the partner, its action. See here, here's unstable. What I said to you, carbon neutral condition is stable. If carbon having positive charge unstable, and carbon having free radical also unstable, and carbon having negative charge also unstable. If you catch this logic, that's all. This topic is very easy for you, students. Carbon positive, positive means deficient, deficient means unstable. He will take electrons from someone, he will get stabilized and go to the neutral condition, stable condition. Free radical, free radical also unstable, he also take electrons from someone, he finally go to the stable condition, neutral condition. Carbanion, carbanion is electron rich, acts as nucleophile, he acts as electrophile. We have taken previous video, no, discussed all these points. Carbanion, he is also unstable, electrons more also unstable, electron less also unstable, neutral condition only stable. He is unstable, no? Now how he will get stabilized? He will give it to someone. Above cases taking and getting stabilized. stabilizing, but he is giving and getting stabilizing. Finally go to the neutral condition. So this is important point. If you understand this key point, that's all. This reaction intermediates is very easy for you students. Okay, now next one, next reaction intermediate. Once you understood free radical, almost it is same carbocation. Free radical stability order, carbocation stability order, almost same. That's why don't confuse. First two topics same. Next topic is reverse, like that you can remember. Carbocation or carbonium ion. These are positively charged ions in which carbon taking positive charge. Already had explained in the previous video how it generated. Please go through that. Now actual point I am going. See, this is methyl chloride. This is what students? Methyl chloride. Methyl chloride, some reacting species, some reagents. What is the reagent here? Nucleophile is attacking. Attacking time, what happened here? Bond cleavage. After bond cleavage, what happened students here? This chlorine is taking electrons and going, and carbon is giving. Who is giving? Carbon is giving. Giving means what is the charge? Positive charge. This is what we call it as heterolysis. Heterolysis, already we have discussed in the previous video, right? Heterolysis. Finally we will get here carbonium ion. Carbonium ion. Now I am talking about carbonium ion. In the valency shell, it has 3 bond pairs. That means see, 3 hydrogens are there, no? 3 electrons, 3 bond pairs, and it has 1 positive charge. Positive charge is nothing but deficient, you no need to write, just you can show. And carbon atom is sp2 hybridization. Free radical sp2 hybridization, even this one also sp2 hybridization. You can apply that formula also. What is the formula I have given in chemical bonding chapter students? What is the formula? Anyone remember? Half into V plus, half into V plus M minus C plus A. So half into, what is this valence electrons here? Here valence electrons 4, carbon, plus 3 hydrogens are there, plus 3. Next, anion or cation? This is cation, right? See, look into this. Cation. Cation or anion. Cation is nothing but we have to subtract -1. Then what you will get? 6. 6 by 2 means what? 3. 3 means sp2 hybridization. You can go for calculation like this also. sp2 hybridization. Who is having sp2 hybridization? Definitely it can show triangular geometry. Planar triangular geometry. Its bond angle is 120 degrees. 120 degrees like this. Okay, so if you want, you can write this is hydrogen, hydrogen, hydrogen. Okay, positive charge. Positive charge you no need to show. Now stability order. Stability order, same story, above key point. He is electron deficient, no, he doesn't have electrons. So this ring, this is cyclopropyl ring. Cyclopropyl methyl carbocation. Cyclopropyl. Propyl means 3 carbons, right? Cyclic ring, cyclopropyl methyl carbocation. Highly unstable. This ring having more strain. Because of more strain, is highly unstable. Highly unstable means more reactive. Which is highly unstable in our chemistry, that is more stable. Fastly is breaking the bond and fastly is giving electrons. Giving electrons means get stabilized, no? And he is also ready to give electrons. He is also bond breaking and ready to give electrons. So finally, so he is more stable, right? This deficient, no, carbon having positive charge is nothing but deficient. Somebody is giving electrons means happily it can stabilize, it can stay sometime. Stability order. Okay, he is more stable. Then 2 rings are giving here, 2 rings are giving here. Here 1 ring is giving. Afterwards tropylium ion. Tropylium ion here also. Pi electron shifting. Pi electron shifting it is giving. So this pi electron shifts here, this pi electron shifts here, like this. Or else you can show like this. This pi electron shifts here, here. is in conjugation. Because of this conjugation, tropylium ion is more stable. Okay, after explanation of electronic effects, this topic is more easy. Okay, starting whenever you listen, it may take time to understand, but again you can read these points, definitely you'll get clarity after listening electronic effects. Okay, next one, triphenyl. Above cases I have shown, no, same thing. Instead of writing benzene ring, phenyl means like this. This is what we call it as phenyl. Instead of writing phenyl, you can write C6H5 also. Both are same. C6H5. That's why I have written instead of writing ring. Okay. Triphenyl methyl carbocation. Afterwards diphenyl methyl carbocation. Afterwards benzyl. Here allyl. See here he is giving electrons. In conjugation, due to conjugation, he is giving electrons, get stabilized. He is not having much electrons, now he is giving electrons, no, stabilize. Next one, here also same story. So he is electron deficient, but three richest guys are there, ready to give electrons, get stabilized. He is poor guy, two Ambanis are there, two rich guys are there, giving electrons. Like this. Okay, methyl, this is what phenyl, least stable is phenyl. It plays very important role for competitive examination students. Triphenyl, tricyclopropyl, next to dicyclopropyl, next to cyclopropyl, next to tropylium, then triphenyl, diphenyl, benzyl, allyl, 3 degree, 2 degree, 1 degree, methyl, phenyl, vinyl. This is the stability order, final stability order. Okay, net stability order. They will compare any questions. Only 3 degree, 2 degree, 1 degree they will take questions, or else above is starting onwards they will ask questions. In between any two they will compare. Different ways they are asking questions here. Please make a note and read twice, thrice. We'll get clarity. So next note, stability of benzyl, allyl 3 degree almost same. This is benzyl, this is allyl, this is 3 degree, almost same. Depends on situation, depends on case we can explain. I will explain different questions in the coming days, then you can understand more better, but note point, please do note it. So stability order is almost same in case of benzyl, allyl 3 degree. Now next last reaction intermediate, that is carbanion. How carbanion comes, students? Carbanion obtained due to heterolysis. These are negatively charged species having carbon. In valence shell, how many electrons, students? It has 3 bond pairs. And one lone pair. Why? Because he gained electron. See, I'll show you this point. CH, okay, next suppose H you can take it, anything you can take it. Now heterolysis, what happens to this? After cleavage, carbon taking electrons, hydrogen is giving electrons. This is carbocation, this is carbanion. See, carbanion. Depends on situation. Sometimes it bear positive charge, sometimes it gets negative charge. Okay, now so in valence shell, carbon contains how many bond pairs? 3 bonds, no? 3 bond pairs and one lone pair. Lone pair also call it as non-bonding pair in the form of negative charge. You can write negative charge, or else you can write negative charge, or else you can write dot also. 2 dots. Dots means one pair of electrons. Both are same. Okay. Free radical means only one dot. 2 dots. 2 dots means electrons. One electron pair he got it. Next, what is the hybridization, students? If you apply the same formula, what is this formula? Half into B plus M minus C plus C. Okay. If you need detailed explanation, chemical bonding chapter, you can go through it in playlist. 4 plus how many? 3 hydrogen. And this is what? Anion means 1. 7, 8 by 2, 4. 4 means sp3 hybridization. Which is having sp3 hybridization? What is the geometry, students? Tetrahedral geometry. Okay, 1 second, let me write one important point. Geometry. Yes, sp3 hybridization having tetrahedral geometry. Many times they ask this question. Geometry they are asking, shape also they are asking. Tetrahedral geometry, pyramidal shape, ammonia molecule. Here lone pairs. Lone pairs equal to 4 minus number of bonded atoms. How many? 3. 4 minus 3, 1 lone pair. We have discussed one lone pair. Negative charge is nothing but one lone pair. See, look into this. Carbon having 3 bond pairs, 1 lone pair. One lone pair is nothing but definitely it is pyramidal shape. It is pyramidal shape. It is diamagnetic in nature. Even carbonium ion also diamagnetic. Only free radical is paramagnetic. Okay. See, actually we expected shape here tetrahedral shape, but it is showing pyramidal shape like ammonia molecule. Geometry which is in sp3 hybridization definitely shows geometry tetrahedral, but actual shape depends on the lone pair. Okay, now students catch one more point. What is that? Carbon neutral condition is stable. If it has negative charge, is it stable? Is it stable? No. Now try to understand the key point. Carbon neutral condition is stable. Carbon having negative charge, is it stable? No. He will give it to electron someone and get stabilized. Give it to someone. Electron rich, more electrons also problem, less electrons also problem. More electrons means he will give it to someone and get stabilized. Less electrons means he will take from someone and get stabilized. Depends on the situation. Depends on the reaction. It can act either carbonium ion or carbanion. Now look into this. To understand more better, I am giving one example. CH3, 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 CH3 minus. Listen carefully this point. See, here carbanion stability order reverse. Free radical and carbonium ion, it is same. Here why it is reverse? Why we are taking its reverse? See the condition. Carbon having negative charge is unstable, right? So he will give it to someone and get stabilized. Who is next neighbor? CH3 group. CH3 group is not ready to take. He is not ready to take. Why? Because CH3 group also electron rich. He is also rich guy. He is also rich guy. Rich guys again he won't take, no. He won't take, no. So listen carefully. So he is carbon C minus. C minus is highly unstable. He will give it to someone and get stabilized. But who is someone here? Methyl group. Methyl groups are electron releasing groups. Methyl groups are electron giving groups. Electron releasing groups. Giving is not correct word. Electron releasing groups. They are ready to give. They are not ready to accept. He is giving. He is giving. He is also giving. First of all, he has more negative charge. First of all, he is highly unstable. He is searching to someone to give electrons, but someone also ready to give. Someone not ready to take. Then what happened? Stability collapse. Less. Right or not? So, suppose this is there. Okay. Carbanion. Here someone is not taking, he is not giving. At least somewhat it is stable. But here he is ready to give, but no one is taking, and the other also ready to give. Then it is much more unstable. Much more unstable. That's why. So tertiary carbanion is highly unstable. And why free radical case, carbonium ion case, carbanion, first three no change. First three no change. Up to here. Alkyl it is no change. Allyl no change. Why? Because here also it is in conjugation. Negative charge comes like this. This guy comes like this. Then what is the output I am writing here, students, to understand more better this one. So little confusing, but it is very easy after understanding the topic. See, I am writing here CH2 minus CH double bond CH2. Imagine the same logic here. What is the logic? He is having charge. Negative charge is unstable. He want to give it to someone. Yes, he is pushing this negative charge here. Once the negative charge comes here, what happened? This carbon now 5 bonds. Here 2 bonds. Here this is okay. This carbon. Look into this carbon. Here upcoming bond, new bond. Finally 2 bonds here. This is 3. This is 2. 5. 5 bonds he can't bear. Then immediately this bond shifts here. Then what is the output here? Write down CH2. Here given electrons, no, double bond. Next, as it is CH, you can write, and he has taken no CH2 minus. See, what is the difference between this? Here double bond, negative charge. Here double bond, negative charge. Just reverse. That means distribution. The negative charge is distributing. The negative charge is taking and again giving. This is giving. This is taking. Like this, some conjugation. That point we call it as conjugation. Is in conjugation. So that means if this carbon can't bear means it shifts to here. This carbon can't bear means shifts here. Like that it is happening. Finally, it gets stabilized within the molecule. That we call it as conjugation. So I said one point to you. After explanation, electronic effects, this topic feels more comfortable. But keep it in mind what I had explained, all the points. Who are studying second year students, for you it is easy. But while listening time you can catch many points. But who are first year students, who are listening first year students, so little confusion is there. But once completed electronic effects, then you can understand more better. Okay. Finally understood. Triphenyl more stable. Then I said one point to you students. Benzene ring acts as both. Benzene ring. So look into this. First you complete here. Triphenyl, then diphenyl, benzyl, allyl, alkynyl. Alkynyl. This is sp hybridized. Sp hybridized is more electronegative. Sp hybridized is more electronegative. He will take electrons. And next to then primary, then to secondary, tertiary. See here volta. 3 degree, 2 degree, 1 degree. But here volta, 1 degree, 2 degree, 3 degree. So please keep it in mind. So I will show you another example. What is that? Yes, benzene ring, it acts as both electron releasing group, electron donating group. Electron releasing group, electron withdrawing group. Electron withdrawing group. Here also writing stable, here also writing stable. Why? Because this is benzyl carbocation, this is benzyl carbanion. Both are stable. Benzyl carbanion. Why? Because see, benzene ring, what is the note point, students? Note. Acts as both electron releasing group, electron releasing, and electron withdrawing. Withdrawing, new word. Withdrawing is nothing but taking. Releasing means giving. Okay, to understand more you can write shortcut. Taking, giving. Okay, it acts as both. See here, situation demanding, need electrons. Yes, we will give electrons. Here situation is demanding, I have to give electrons, right? Then he is giving electrons. So he is giving electrons and gets stabilizing. He is taking electrons and gets stabilizing. Finally, our benzene ring acts as both. That's why first 3 cases it's same. Triphenyl, diphenyl, and benzyl allyl up to there it's same in carbocation case, carbanion case, free radical cases also. Last 3, what is that? 3 degree, 2 degree, 1 degree, there only confusion is there. Please try to understand. Carbonium ion case, free radical case, it is same. Carbanion is reverse. Okay students, this video it is taking nearly 35 minutes, but it plays very important role in organic chemistry. Please listen 2 times. If you are not understanding, 3 times, make a note. Wherever you are feeling difficult, comment me. Definitely that topic again I will do in the upcoming videos. Okay students, thank you. Thanks for watching.